Hello students. So in the last class we have discussed Cauchy's theorem, Cauchy's integral formula for derivatives and generalized Cauchy's integral formula. So in this class we will discuss the examples on all those four theorems. So first one, evaluate integration over c e power z divided by z plus I pi dz over each of the following curves. So that the first curve is mod z equal to 2 pi and mod z equal to pi by 2 mod of z minus 1 equal to 1. So here the given curves are the circles having the equations mod of z minus a is equal to r. So where a is the center and r is radius. So here we need to evaluate the integral e power z divided by z plus I pi dz. So first let us compare that e power z divided by z plus I pi, that given integral, with the standard one. So here the standard integral will be of the form integration over c f of z divided by z minus a dz, right? So on comparing the given integral with the standard one, we can write that f of z equal to e power z and z minus a is equal to what? Z plus I pi. Then it implies that the center of the circle a is equal to minus I pi, and coordinates of this center. So here real part is 0 and the imaginary part is minus pi. So therefore 0 comma minus pi is the center of the, so the 0 comma minus pi is the coordinates of the point A. And now we need to start with each of the curves. So the first one is mod z is equal to 2 pi. So here center of this circle is 0 comma 0 and radius is equal to 2 pi. So now here in the last video, so we came to know that there are two important points. So if the point lies inside the circle and outside the circle, then the value of the integral will be different. So if the point is inside the circle, then value of the integral is equal to 2 pi I into f of a. So if the point lies outside the given curve, then the value of the integral is equal to 0. So therefore here now we need to check whether the a means from the given integral, whatever we have chosen the a, so that point should be inside the given curve. So if it lies inside the given curve means mod z equal to 2 pi, then we can evaluate the value of the integral at a. Otherwise that is equal to 0. So now we need to find the distance between the center of the given curve and the point A by using the distance formula. So if that distance is less than the radius, then the point lies inside the circle. If it greater than 2 pi, then it lies outside the circle. So let us compare. So let us take this as point A and let us consider this as the point P. Then the distance A into P is equal to what? Square root of 0 minus 0, that is 0 whole square is 0 plus 0 minus of minus pi, that becomes plus pi whole square that is pi square, and it is pi. So here the distance of, or the distance between two points, means both are the centers only. So here z minus a means a is the center of given curve. So therefore here the distance between these two centers is less than the radius of the given circle. So therefore here the point means this one, 0 comma minus pi. The point lies inside mod z equal to 2 pi. Therefore now we can evaluate that. Integration over c e power z divided by z plus I pi dz is equal to 2 pi I into f of a. So here this is equal to 2 pi I f of a. A is equal to what? Minus I pi, and f of z equal to e power z. So therefore now f of a becomes f of minus I pi, which is equal to 2 pi I into e power I pi minus I pi. And to evaluate that e power minus I pi, we know that e power I theta equal to cos theta plus I sin theta. So by using that condition or that definition, here we can evaluate the value of e power minus I pi. So therefore here this is equal to 2 pi I into cos pi minus I sin pi. So we know that sin pi is 0 and cos pi is 1, or minus 1. So therefore that is 2 pi I into minus 1, which is equal to minus 2 pi I. So that is the value of the integral. That is integration over c e power z divided by z plus I pi dz equal to minus 2 pi I, which is the required value of the integral. And the next curve is mod z equal to pi by 2. So for this circle, it implies, let us consider a as the center. So a is equal to 0 comma 0, because it is z minus a. So here a is 0 and radius is pi by 2. Then let us choose AP, the distance. So here in the previous case also a is 0 comma 0 and the point P is 0 comma minus pi. Here also a is 0 comma 0 and the point will be same for all these three curves. So therefore the distance will be pi only. Now AP is equal to pi, but here pi is greater than pi by 2. So if the distance between those two centers is greater than the given radius, then the point lies outside the circle mod z equal to pi by 2. So therefore it implies that the point lies outside mod z equal to pi by 2. So whenever the point lies outside the circle, in that case the value of the integral is equal to 0. So therefore integration over c e power z divided by z plus I pi dz is equal to 0. Here no need to evaluate the integral. So if you evaluate also, we will get the same answer, that is 0. So here we can evaluate by the same condition, that is 2 pi I f of a, where a is equal to what? Minus I pi, and f of z equal to this e power z but here since the point lies outside the given circle, so by using that note you can directly evaluate its value as 0. So this is no need to evaluate whenever the point lies outside the circle. and the last circle is mod z minus 1 equal to 1. Third one, mod z minus 1 is equal to 1. So for this circle, a is equal to what? 0 comma 1. Sorry, here a is equal to 1, it implies that capital A is equal to, the real part is 1 and the imaginary part is 0, means that is 1 comma 0. So here whatever the points are given, they are all the complex variables, so therefore they will be in the form of a plus ib. So therefore we need to consider real part and imaginary part separately. So if imaginary part is there, means that should be multiplied by I. So but here a, in case of a is equal to 1, there is no I term, means the imaginary part is 0 and the real part is 1, and radius is equal to 1, and the point P is equal to what? 0 comma minus pi, that is common for all the three circles. Then here p is equal to 0 comma minus pi, then AP is equal to distance between these two. Now 1 minus 0 or 0 minus 1 whole square plus minus pi minus 0 whole square, then it is equal to square root of minus 1 whole square is 1 plus pi square. So here pi radius is 1, then this quantity will be greater than 1 because the value of pi is 3.142. So 3.142 whole square, that is near about 10, then here plus 1 is there, the total quantity will be greater than 1. So therefore point lies outside the circle mod z minus 1 equal to 1. So therefore integration over c e power z divided by z plus I pi dz equal to 0. So it is very easy to evaluate whenever the point lies outside the circle. If the point lies inside the circle, then only that its value is equal to 2 pi I f of a. Otherwise it is equal to directly 0. No need to evaluate the integral. Now evaluate integration over c dz divided by z square minus 4. So in this case the given problem is not in the standard form. So what is the standard form? Integration over c f of z divided by z minus a dz, right? So here we have f of z in the numerator, okay, no problem, but in the denominator the power of z must be is equal to 1, but here the power of z is 2. So therefore we need to reduce the power of z in denominator is equal to 1, and then we need to proceed. And here given curves are mod z equal to 1, mod z equal to 3, and mod z plus 2 is equal to 1. So here we cannot write directly the value of a because it is not in the standard form. That should be of the form z minus a. So now consider integration over c dz upon z square minus 4. So dz upon here z square minus 4 is in the form of a square minus b square. So therefore that can be written as a plus b into a minus b. So therefore here it is z minus 2 into z plus 2, right? So now also we cannot write the value of a because there are two terms in the denominator. That should be only one factor in the denominator. So therefore let us separate this as integration over c 1 divided by 4 times z minus 2 minus 1 divided by 4 times z plus 2 into dz. So here by using partial fraction. So already you know what is partial fraction and how to find the factors, right? So therefore 1 by 4 is the value of a and b, capital A and capital B. So therefore here 1 by 4 z minus 2 minus 1 by 4 z plus 2 dz. Then it is equal to 1 by 4 into integration over c dz upon z minus 2 minus 1 by 4 integration over c 1 divided by z plus 2 dz. So consider this as equation number 1. So means in equation 1 we have two integrals, and in the first integral the value of a is equal to 2, and in the second integral a is equal to minus 2. So means here we need to check the condition for the point A, whether it lies outside or inside the circle. So here we need to check the condition for both the integrals, because in the first case a equal to 2 and in the second case a is equal to minus 2. So let us consider a1 and a2. So a1 is equal to what? 2. It implies it is 2 comma 0, and a2 is equal to minus 2. It implies minus 2 comma 0. So here this point, let us consider this as P1 and P2. The first point is 2 comma 0 and the second point is minus 2 comma 0. Then the given circle, let us consider the first one. So mod z equal to 1. So here the center of this circle is 0 comma 0 and radius equal to 1. Then we need to find two distances here, because in the previous problem there was only one point P, but here P1 and P2 are there. So therefore A into P1 is 2 comma 0. So therefore that is 0 minus 2 whole square plus 0 minus 0 whole square, which is square root of 2 square, right? Square root of 2 square means it is 2, which is greater than 1. It implies P1 lies outside the circle. And similarly we can check the condition for P2. So let us consider that as a P2, that is 0 comma 0 and P2 is minus 2 comma 0. Then 0 minus of minus 2, that is 0 plus 2 whole square plus 0 minus 0 whole square, that is square root of 2 square, which is 2 greater than 1. So it implies P2 lies outside the circle mod z equal to 1. So means both the points P1 and P2 lies outside the circle. So therefore from equation 1 integration over c dz upon z square minus 4 is equal to 1 divided by 4. So here integration over c dz upon z minus 2, the point lies outside the circle, so therefore its value is 0 minus 1 by 4 into 0, therefore the total value of integral is 0 here, since both the points lies outside the circle. The equation of the second circle is mod z equal to 3. So here it implies that the center is 0 comma 0 and radius is equal to 3, right? And we know that the point P1 and P2, so P1 equal to 2 comma 0 and P2 is equal to minus 2 comma 0. So therefore here AP1, so AP1 we have already evaluated in the first case, that is 2, right, which is less than 3. So in this case radius is 3, so therefore here that AP1 is equal to 2 and less than 3. Therefore, P1 lies inside the circle. Mod Z equal to 3. And AP2 is also 2, which is less than 3. Hence, P2 lies inside the circle mod Z equal to 3. So therefore, from equation 1, so here from equation 1, integration C dz upon z square minus 4 is equal to 1 by 4 2 pi I into f of a, that is the value of the integral, because here integration over C f of z divided by z minus a dz equal to what? 2 pi I into f of a. So this is the Cauchy's integral formula. So therefore, by using that one, the value of the integral is 2 pi I into f of a, and a is equal to what? Minus 2 minus 1 by 4 2 pi I f of plus 2, right? Then it is 1 by 4 into 2 pi I. So what is f of z here? In numerator there is no function, means that is equal to 1, the constant function. So hence, whatever may be the value of a, that f of z will be equal to 1 only. Hence it is 2 pi I into 1 minus 1 by 4 into 2 pi I into 1. So therefore its value is equal to 0. So here in this case, even though both the points lies inside the circle, its value of integral is equal to 0. So here value of the integral equal to 0 means the point, it doesn't imply that the point lies inside the, outside the circle. So in some cases, even though the point lies inside the circle, we can get the value of the integral as 0. So here that is not the necessary and sufficient condition. That is only one way. Means whenever the point lies outside the circle, then the value of integral is equal to 0. And it doesn't imply that whenever the value of the integral is equal to 0, then the point lies outside the circle. That is not true. And the last circle, that is third one, mod z plus 2 is equal to 1. So here a is equal to what? Minus 2, because the standard form is z minus a, but here it is z plus 2, means a is minus 2 and the point a is minus 2 comma 0 and radius is equal to 1. So therefore here the center of the circle is minus 2 comma 0, and we know the points P1 and P2. So P1 is minus 2 comma 0 and P2 is minus 2 comma 0. So therefore let us find here P1 is 2 comma 0 and P2 is minus 2 comma 0. Then AP1 is equal to square root of 2 minus of minus 2, that is 2 plus 2 whole square plus 0, which is equal to 4 square, that is square root of 16, which is equal to 4 and greater than 1, because here the radius value is 1. Hence we got the radius as 4, which is greater than 1. It implies that point P1 lies outside mod z plus 2 equal to 1. And let us evaluate AP2. P2 is minus 2. So here minus 2 minus of minus 2. minus 2 minus of minus 2 is plus 2 whole square plus 0. So total its value is equal to 0 because minus 2 plus 2 will get cancelled. It is 0, which is less than 1. So it implies P2 lies inside mod z plus 2 equal to 1. Then from the equation 1, so here equation 1 is this one, integration of c dz upon z minus 2. Here its value is equal to 0 because the point P1 lies outside the circle and its value is 2 pi I into f of a. So therefore here integration over c dz upon z square minus 4 is equal to 1 by 4 into 0 because for the first point lies outside minus 1 by 4 into 2 pi I f of a. So here a is minus 2. Then it is 1 by 4 into 0 minus 1 by 4 into 2 pi I because f of z is 1 and f of minus 2 is also 1. Hence it is equal to minus 1 by 2 pi I because it is 0 and here 2 ones are 2 2s are minus pi by 2 I is the value of the integral, which is minus pi by 2 I. That is the value of this integral. So therefore for all the three circles we have evaluated the value of the integrals. So here first we need to check whether the point lies inside the circle or outside the circle. If it lies outside the circle, then the value of integral is directly 0, and if lies inside the circle, then we need to evaluate that by using the formula integration over c f of z by z minus a into dz is equal to 2 pi I f of a, and the condition is that in denominator the power of z must be is equal to 1. If it is greater than 1, then we have to reduce that to 1 by using the suitable identity. And if it is of the form integration over c f of z divided by z minus a whole power n dz, for that we have the generalized Cauchy's integral formula. So therefore here it may be of the form z minus a whole square or z minus a whole cube whole power 5, but the factor should be of the form z minus a only. That is compulsory.